Hi everyone. Let's take a look at number 16 on page 147. A north-south highway intersects an east-west highway at point P. A vehicle crosses P at 1 p.m., traveling east at a constant speed of 60 kilometers per hour. At the same instant, another vehicle is 5 kilometers north of P, traveling south at 80 kilometers per hour. Find the time when the two vehicles are closest to each other and the distance between them at this time. Step 1. Draw a diagram. If you go back to the first sentence, it says a north and south highway, so this is north, this is south, intersects with the east-west highway at point P. So east and south, and there's a point P. In the second sentence, a vehicle crosses P at 1 p.m. So write down a let statement. Let T be the time after 1 p.m. So again, the starting point in terms of actual time is 1 p.m. The second let statement is going to be let D be the distance between the two vehicles. So, if you go back to the second sentence, a vehicle crosses P at 1 p.m., traveling east at a constant speed of 60 kilometers per hour. So, the vehicle is going this way to your right, and it passes the point P. Now, if you form a triangle, which we will eventually in a moment, this part is going to be vehicle number 1. And vehicle number 1 is going to the right, or is traveling east. At the same instant, another vehicle 5 kilometers north of P. So 5 kilometers could be roughly somewhere here. This distance is 5 kilometers. And the vehicle is traveling south at 80 kilometers per hour. So 80 kilometers per hour is the speed. And again, this is vehicle number 2. So when you connect this, that's going to be the distance, which we already defined in the let statement, the distance between the two vehicles. Now, you have to remember a couple of basic concepts. For example, you have to remember that distance equals the speed times time, or displacement is velocity times time. If you go back to this first part, you need to figure out the distance. And since distance is speed times time, and the first vehicle is moving at 60 kilometers per hour, this means the distance is going to be 60 times t. Likewise, if you look at the second vehicle, it's going south at 80 kilometers per hour, and it's 5 kilometers north of P. So this distance is going to be 5 minus 80t. Again, 5 is distance. 80t is also distance because it's speed times time, and it's negative because as the vehicle is getting closer, the distance is going to be less than 5. So 5 minus 80t. There are two things you're looking for. Find the time and the distance when the two vehicles are the closest. So you have to minimize the distance. Minimize the distance between the two vehicles. And of course, if you focus on this, right, you have to think c squared equal to a squared plus b squared. Because this is a right angle triangle, and when you isolate for d, that's going to be the square root of 60t in brackets square plus 5 minus 80 times t quantity square. Again, at this point, you can expand this first. So this becomes 3,600 t squared plus 25 minus 2 times 5 times 80, so 800t plus 6,400 t squared. Now we can differentiate this, set it to 0, solve for t. So don't forget the basic rules. When you take the derivative of a square root, you bring the half to the front. But the half means the 2 goes at the bottom. You copy it to the power of -1, or not -1, negative half, which becomes positive half at the bottom. And again, notice you can collect like terms. So this will give you 10,000 t squared plus 25 minus 800t. And you multiply this by the derivative. So when you differentiate what's inside the square root, that's going to give you 20,000 t plus 0 minus 800. Now, when you set this to 0, the only part that matters is the top. So again, we've talked about this one before. If you cross multiply or you can dismiss the bottom, you only focus on the numerator. Now, you can cross out the 2 zeros. You can divide both sides by 100. We're going to divide this by a little bit more. But if you bring -8 to the left, that's +8, which equals to 200t. The opposite of multiplying is a divide. Time is going to be 0.04 hours. Now, you have to be mindful because they're not asking for the amount of time. They're asking for the actual time in terms of the time of the day. So your starting point is 1 p.m. Your starting point is 1 p.m. So you have to go back and say, well, what time would it be if it's 1 p.m. plus 0.04 hours? So if you look at 1 p.m. and you're adding it by 0.04 of an hour, you can rewrite this as 1 o'clock and 2 minutes. So again, 1 hour has 60 minutes. You can take 0.04 times 60, and if you round this, it's approximately 1:02 p.m. Now, you also want to find a distance. That's the second part that you're looking for. So to find a distance, you have to plug this back in. So if you took time, which is 0.04 of an hour, and you plug it back in, this will give you the minimum distance. And again, this you can work out on your own, and it's going to be 3 kilometers. Now, the last idea is this. How can you tell that these answers is the minimum and it's not the maximum? All you have to do to double check your work is to draw a number line and look at the point 0.04. And of course, don't forget to add in 0 on the timeline. What happens is if you take different numbers, for example, a number between 0 and 0.04, let's say 0.01, or a number greater than 0.04, let's say 0.05, and you plug it back in to the derivative, what happens is you would discover that this is negative, which is decreasing. This is positive, which is increasing. And if the function decreases, then continues to increase, this means the critical point must be a minimum. I hope this makes sense.